In today's lesson, I'm going to do a couple of examples on arithmetic series. So the first one which I'm going to do is the first term of an arithmetic series is 5 and the last term is negative 55. The series has 15 terms and then you have to find the common difference and the sum of the series. So first thing, to quickly recap, Sn, the sum of n arithmetic terms are n over 2, 2u1 plus n minus 1 into d. So this is one formula, or it is n over 2 u1 plus un. So you know u1 is the first term, n is the number of terms, d is the common difference, and Sn is the sum of n terms. So I'm going to first draw the information and use proper notations to express what they are asking us, what is given in this question. So arithmetic series, so AP, it's an arithmetic series. The first term, which means u1 is 5, and the last term, which is, let's say, un, which is equal to negative 51. The series has 15 terms, which means n is 15, and you have to find the common difference. So we already know un is negative 15, and we also know un is u1 plus n minus 1 into d. So negative 51 is equal to 5 plus n minus 1 into d, and n is 15, so I'm going to substitute this here, and 15 minus 1 into d, so minus 56 divided by 14 is equal to d, so negative 4 is your d. So the common difference is negative 4. Now the next one, the sum of the series, and we already know un, so the formula which we should be using is this one. So Sn is equal to n over 2 u1 plus un, and we are finding S15, so this is 15 over 2, u1 is 5, and un is negative 51. So this becomes 15 over 2 and multiply by negative 46, and when you multiply this, this is going to be negative 345. So this is your S15. So that was your question number 1, where the first term and the last term and the number of terms were given, and you were supposed to find the common difference and sum of the series. The second example is the first term of an arithmetic series. So first thing you should do is to note down what kind of sequence or series they are talking about. So I'm going to write down, so arithmetic series here, and the first term of an arithmetic series is given, that's negative 7. The fourth term is given, which is 23. The sum of the series is 689. Now you have to find the number of terms, so you have to find the value of n. So n is not given here. So now let's start with, we already know u4, which is equal to u1 plus 3d, and u1 is already known. So 23 is equal to negative 7 plus 3d. So 23 plus 7 divided by 3 is d. So which means d is equal to 10. So we know the common difference now. Now let's substitute Sn is equal to n over 2 2u1 plus n minus 1 into d. So this is what we have, or we can use the formula n over 2 u1 plus un. So what I'm going to do here is I'm going to write down what is un here. So u1 plus n minus 1 into d. I already have u1, which is negative 7, plus n minus 1, we don't know n, but d is 10. So un in this case is negative 7 plus 10n minus 10. So 10n minus 17 is my un. So now it doesn't matter. I'm like, I could have used this formula, or instead of using this formula, if I wanted to use this formula, so I found un separately. So, but you can also use this formula. So Sn is equal to n over 2 u1 plus un, and here Sn is 689, n we don't know, and then u1 in this case was negative 7 plus 10n minus 17. So 689 multiplied by 2 is n, collect like terms, minus 24, and if I open this bracket and simplify it further, so this is equal to 1378 10n square minus 24n. So I'm going to move everything on one side, keeping the coefficient of n square positive, keeping the leading coefficient positive. So 10n square minus 24n minus 1378 is equal to 0. Now the numbers are big, so you don't have to use do by hand, factorization by hand, or discriminant rule by hand. So I'm going to do is I will use the calculator. and the steps to use the calculator are, so this is TI-84 plus CE calculator. The steps are same for TI-84 as well. So you need to go to apps, which is applications, and then you go to number 9, which is PLY SMLT2 application, and then you need to use polynomial root finder, and the order of this it's a quadratic, so the order is 2, so we don't have to change anything here. Go to next, and now we need to change the values. So as you can see that it will be on the black color cursor is on the number, so you can change the number. I already input those numbers, so for if you click on this, I can do that, and then I can change the number if I had to. And similarly, they will ask you to change the second step to change negative, positive, negative. So you can enter using the numbers and using these negative, positive, you will get this equation here. And then I'm going to move to the solve. And then I can see my x1 is negative 53 over 3 and 13. So we cannot have a number of terms as a fraction and negative. So which means the answer for number of terms is 13. So we cannot have negative 53 over 3. That is rejected. So 13 is your final answer. So n is equal to 13. The next example is you have to find the value of summation R from 1 to 28, 5R minus 4. So I'm going to do this by hand first, and then I will show you how to use graphic display calculator to check your answer. So first step I'm going to do is the summation means we have to find the sum of the series or the numbers which is generated by this rule. So I'm just going to write down when R is equal to 1. As you can see from the rule, it's an arithmetic progression. So for U1, it's going to be 5 minus 4, which is 1. And for U28, because now I'm going to use this formula n over 2, U1 plus UN. So U28 is going to be 5 times 28 minus 4. So which is equal to 5 times 28 is 140 minus 4. So this gives you 136. So this is your U28. And now I'm going to I will start substituting the value. So n is 28, 28 over 2, 1 plus 136. So 14 times 137. So you got 1918. That's your S28. So that's your final answer. So you should know how to do it by hand, but I'm also going to show you how to do using calculator. How can we use calculator to check it? But again, I'm saying you have to use the calculator only to check it. So what you need to do is you need to go to math. When you go to math, you go all the way down, and then there is a summation, which is 0 gives you the summation, and then you press on enter, and then I'm not going to change this x into n. You can do it, but I'm going to keep it as x. And x start from 1 to 28. And then you input your rule, which was in this case was 5x minus 4. So negative 4. And then you press on enter. So you got exactly the same number, 1918 here. The last one here is, I'm going to do this question in 2 different ways. So my first way is, the sum of an arithmetic series is given by Sn is n into 2n minus 3. Again, it's an arithmetic series. Find the common difference in the first 3 terms. So what is given is Sn is n into 2n minus 3. And you have to find the common difference and U1. Okay, so the first thing I'm going to do is, I'm going to rewrite. I know Sn is n over 2 U1 plus Un. And since I have n here, so what I'm going to do here is, I'm going to divide this by 2 and multiply this by 2. So I'm trying to make this look like the formula we have here. So this is n over 2. This is 4n minus 6. Now I can compare them and can see that my U1 plus Un is equal to 4n minus 6. And I know how to find U1 because Sn is equal to n into 2n minus 3. So S1 is going to be negative 1. And if you remember, S1 is same as U1. S1 is sum of one term, which is same as U1. So my U1 is negative 1. So negative 1 plus Un is 4n minus 6. So I got Un, which is 4n minus 5. So once I have Un, I can find U2 which is 4 times 2 minus 5, which is 3. And then I can find the common difference, which is equal to 3 minus negative 1, which is 4. So this way I can find the common difference. And first 3 terms, they ask you to find first 3 terms. So you can also do U3 here. So 12 minus 5, which is equal to 7. And here also you can see the differences 4. So this is one way of doing it. And now I'm going to do differently here. So SN is, so our SN is n 2n minus 3. So this is my second way of doing. So here again I can substitute S1, which is 1 into 2 minus 3. So S1 is negative 1 and S1 is same as U1, which means U1 is negative 1. So that step is same for both. Now you do S2, 2 into 2 times 2 minus 3. So 2 times 4 minus 3, which is equal to 2 times 1. So S2 is 2, but we also know S2 is same as U1 plus U2. And U1 is same as S1, which means S2 minus S1 is U2. And now your second term is 2. This is negative 1. So you will get U2 as 3. Now similarly, you will find S3, which is U1 plus U2 plus U3. And then you can find S3 by substituting here. So S3 is equal to 3 into 6 minus 3, which is 9. So 9 is equal to, you already have U1 plus U2, which is your S2. You already had that 2. So 2 plus U3, and U3 is equal to 7. So this is the another way of finding the first 3 terms. And then you can find the common difference because you know negative 1, 3, and 7. So 3 negative negative 1 gives you 4. 7 minus 3 gives you 4. So common difference is 4 here.